Okay, in order to solve a polynomial equation that is in standard form, we're going to have to factor it into factored form. And so what I want to do is just a brief review of factoring. Okay, in this situation right here, we're going to do a greatest common factor. In this one, we're going to do product sum factoring. In these two, we're going to use a technique that's called a difference of squares factoring. And then in this one right here, we're going to use a technique called factoring by grouping. Now, if you need more of a review than I'm giving you here, you will need to look up videos on how to factor, and they shouldn't be hard to find. There are plenty of them around. Okay, so in order to factor this one right here, okay, we're just going to factor out what the greatest common factor. You can see that there is an x in this term and there's an x in this term. And that means that we can divide each one of them by x. When we divide by x, it'll cancel an x in each one, and then we will be able to take an x out, and that will become x times x plus 5. Okay, so what we've done is we've undistributed. If we were to distribute this x, it would be x times x is x squared, and then x times 5 is 5x, which is what we started with. So all we really did was we took one x out of it, and we came up with x times x plus 5. In this next one right here, I want to remind you that this is a quadratic, and what we're looking for is here, we're looking for two numbers that multiply to negative 14, but add up to negative 5. And I can think of two numbers that multiply to negative 14. They are negative 7 and 2. And if you add negative 7 plus 2, you would get negative 5. And therefore, our two numbers are negative 7 and 2. And so we're going to do x minus 7 times x plus 2. So the way we do that is we take our two numbers, the negative 7 and the 2, and we put them each in parentheses with an x to the first power, and now we have two factors. So we've turned this one into factored form. Okay, this one is a difference of squares, and the way you know is it's always subtraction. And in addition to the subtraction, we'll have an x squared on the left, and we'll have an x, a number that's a square on the right, and 25 is a square. Now I'm going to show you down here how you can actually do it without a perfect square. You can do it with a non-square. I'm going to show you that in a minute. Basically, this just turns into two sets of parentheses, just like this one up here. Okay, two sets of parentheses. Each one starts with an x. Okay, and then what we do is one of them gets a plus, one of them gets a minus. And then we take the square root of this number. The square root of 25 is 5. So we'll put a 5 here and a 5 here. Okay. All we're doing is reviewing. You should have already seen this before. Okay. So this is the same thing as x plus 5 times x minus 5. And it's now in factored form. We can do the same thing here. We can set up our two sets of parentheses. It's a difference. So we can go x plus and x minus. But now what we're going to do is we're just going to do the square root of this number. And the square root of 7 is just the square root of 7. So we're going to put the square root of 7, square root of 7, and we're done. Okay. Now there is another variation of this where we actually can take x to the 4th power minus 25, and we can factor this also into two parentheses. It's still a difference of squares. Okay. But this time we're going to have x squared plus and x squared minus. It's just basically x to the 4th is the same thing as x squared squared. X squared squared is x to the 4th. Okay? And therefore, x to the 4th is a perfect square. It's just the square of x squared. So we would do x squared plus 5 and x squared minus 5. And look here, we now have another difference of squares. We have x squared minus 5. So now that can be broken down into x plus the square root of 5 and x minus the square root of 5. Okay? And that's just a little additional review here. I don't know if you've seen that part before, but it's something that you can do if you have a difference of squares, but it's with an x to the fourth power. Okay. All right, and so this last part here, this one is going to be done by factoring by grouping. Okay. Now, factoring by grouping, remember we're just reviewing here. Okay. And with factoring by grouping, what you have to do is you have to group your, it's usually a four-part polynomial, okay, that is to the third power, okay? And what we're going to do is we're going to break it up into two sets of parentheses like that, okay? But I'm going to do it separately because I want to move this negative closer to the 49, okay? And I'll show you what I mean. I'm going to rewrite this as x cubed minus 3x squared plus negative 49, which is the same thing as minus 49, x plus 147. Okay. And now I'm going to put parentheses around the first two and parentheses around the second two. And now what I'm going to do is I'm going to factor out the greatest common factor, and I can factor out an x squared because there's an x squared right here. So I can factor out an x squared, and if I divide x cubed by x squared, I get just x. Okay. And if I divide negative 3x squared by x squared, I just get negative 3. So what I've done is I've divided out x squared from both of these. Okay. Then here I'm going to divide out negative 49 because negative 49 is in here. 147 divided by negative 49 is negative 3. And if I divide this by negative 49, I just get x. So I'm going to take out a negative 49, and then I have an x left over, and then 147 divided by negative 49 is negative 3. Okay? And now my factors, what happens when you do this is you should have two identical factors here, x minus 3, but they only count as one of them. So one of our factors is x minus 3, and then our other factor is this thing with this thing. So x squared minus 49 is the other factor, x squared minus 49. Okay. Now I want you to notice that this is a difference of squares. So it can now be factored. It can become x minus 7 times x plus 7, and then it's times x minus 3. Okay. And therefore, this is factored into this. And now we're going to use our knowledge of factoring to find all real zeros for the following functions. Okay? Well, finding the real zeros is the same thing as taking the function and setting it equal to 0 and then solving for x, which is what we did in the previous video. We solved for x. So we're going to set this equal to 0. Okay? And in this first one here, we're going to, you'll see that there's an x in every single term. So we're going to be able to factor out a greatest common factor. We're going to factor out an x. So this is now going to become x times. We're going to take one x out of x cubed, and it's going to become x squared. We're going to take an x out of plus 2x squared, and it's going to become just plus 2x. We're going to take an x out of negative 63x, and it's going to become negative 63. And that's going to be equal to 0. Now, this is factorable by product sum factoring. There are two numbers that multiply to negative 63, and they add up to positive 2. Those two numbers are negative 7 and positive 9. Okay? And so we're going to put an x in front of the negative 7. We're going to put an x in front of the positive 9. And we're going to bring down this x right here. Okay? We're going to bring it down here. And what we now have is we've fully factored it. It's now x times x minus 7 times x plus 9. Okay? And that's going to be equal to 0. And now we want the solutions. So we'll set each one of them equal to 0. X equals 0. X minus 7 equals 0. And then we'll add 7 to both sides. And we wind up with x equals 7. And then x plus 9 equals 0. And we'll subtract 9 and subtract 9. And we wind up with x equals negative 9. And so our real zeros are x equals 0, x equals 7, and x equals negative 9. Now we're going to do the same thing down here. Now this one has to be factored by grouping. We'll take our x cubed minus 2x cubed, or squared. Then we're going to do plus negative 16x, just like we did in the review. And then plus 32, we're going to say that that's equal to 0. We're going to put parentheses here and here. We're going to group them up. Put parentheses there, put parentheses there. Over here, we're going to factor out an x squared. So we're now going to have x squared times x minus 2. Okay? Here, we're going to factor out a negative 16. So we'll take out negative 16, and then we'll have x. Positive 32 divided by negative 16 is negative 2. So we'll have minus 2. This whole thing is equal to 0. Okay? And then this x minus 2, that's only one factor. That's only one factor. X minus 2 equals 0. And then this one is going to be x squared minus 16. So that's going to be x squared minus 16. But this x squared minus 16 can be factored. It's a difference of squares. So we can turn that into x plus 4 times x minus 4, then times x minus 2, and that's going to be equal to 0. Okay. Now what we do is we take each one of these and set it equal to 0. X plus 4 equals 0. X minus 4 equals 0. And x minus 2 equals 0. Okay. Now we're going to subtract 4 from both sides, and one of our solutions is x equals negative 4. That's one of our real zeros. We're going to add 4 to both sides here, and we're going to get x equals positive 4. Good. And then here we're going to add 2 to both sides, and our third solution will be x is equal to positive 2. And there we go. This is how we find all the real zeros for a polynomial function that is in standard form.